n into n minus 1 into n minus 2 into and so on up to 1 you have to multiply. 0 factorial is 1. If you take 4 factorial, you have to write like 4 into 3 into 2 into 1. So which is 24. 5 factorial means from 5 go back till 1. Multiply all numbers to get 120. So that is a simple meaning of factorial. Now, if there are n persons are there and n chains are there, now the number of ways of arranging n objects taking all at a time is n factorial. This is a very fundamental formula in this linear arrangement. In linear arrangement means if objects are being arranged in a line, that is called linear arrangement, linear permutations. If you want to arrange n persons, you can arrange in n factorial ways. Whereas there are n persons and you want to arrange only r persons. So r persons are arranged from n persons, npr. That npr formula is what? This is n factorial by n minus r factorial. For example, there are 10 people are there and you want to arrange 3 people. How many ways you can arrange? 10p 3 ways you can arrange. Which means what? 10 factorial by 10 minus 3, 7 factorial. Now 10 factorial can be written as 10 into 9 into 8 into 7 factorial by 7 factorial. In the numerator and denominator, that 7 factorial gets cancelled. So simply this is the 10 into 9 into 8. So this is expansion for NP or 10p3. So the simple meaning for this expansion is that you don't have any denominator in NPR. While expanding, from 10 go back by 3 times. If I say that let's take 25p3, what is the meaning? From 25 you have to write 3 terms only, 25 into 24 into 23. That's how you have to use this expansion. No need to write down in the specific format every time. And then next formula. Out of n objects, what if repetition of letters are allowable? What if repetition of letters are there? This is done. Now, out of n objects, P1 or one similar kind, P2 or another similar kind, P3 is another similar kind, and so on. Then, the number of permutations of all those n objects is n factorial by the repetition factorial times you have to multiply. Let us take an example. If I take the word leader, how many ways you can arrange the letters of the word leader? There are 6 letters, right? Arranged in 6 factorial ways. By any similar objects, there are 2 is no. So divide by 2 factorial. There is no other letter repetition, right? Only 2 is repeated. Only E is repeated. Let us take one more example. Let us consider the word association. So in the association, there are 11 letters in total. There are 2 A's, 2 S, 2 O's, and 2 I's. There are 4 alike objects now. How do you put it in the formula manner? N factorial by 11 factorial by all similar object factorials you have to multiply. Now 2 times A factorial that, 2 times S, 2 times O, 2 times I. So you have to take in the denominator all the repetitions factorials. Is this clear? Say yes if you understood this point. Now let's move on to the next point. Now coming to the arrangement or selection. Selection means in which order doesn't matter. Here AB selection is same as BA selection, right? AB and BA are the same selection. There is no difference. If you want to select R objects from N objects, that is called NCR. That is N factorial by R factorial into N minus R factorial. Now it is better to know few more applications of this. You may use in mathematics as well. So NCR equal to N factorial by N minus R factorial means NPR by R factorial. So we can write that NPR is R factorial times NCR. And a few more important applications in this is that NC naught is 1, NC1 is N, NCN is 1, NCR is NCN minus R. So if I say that NCP equal to NCQ, then which means that N equal to P plus Q. I am very sure as your MPC background, you might have gone through all these properties in our math part when you start the PNC topic. There is nothing new. Everything you know about this. So say yes if people understood this point.